So we're going to start with number one. Number one, we've got a mapping diagram here. Now, which of these boxes is our input? Is the left going to be our input, or is the right going to be our input? Left, right? Inputs on the left, outputs on the right. Okay. So we've got 4 inputs, 6, 7, 8, and 9. We've only got 3 outputs, right? 3, 4, and is that a 6? It looks like a 6. Yeah, 6. And we're going to have to match one of these 3 sets of ordered pairs to this specific mapping diagram, right? So first things first, we should make sure that our sets all have the correct inputs. Let's focus on the inputs first. Like I said, we've got 6, 7, 8, and 9. Let's take a look at our first option. Our inputs here are 6, 7, 8, and 9. So far, so good. Let's take a look at our second option. We've got inputs of 6, 7, 8, and 9 again. So that one is also potentially going to be our answer. But then we get down to C. And our inputs for option C are 3, 3, 4, and 9. Does that match up with our inputs in the diagram to the left? No, definitely not. We can cross C out right away. We know it's not going to be C for sure. Okay? I don't know why I put. I meant out, but yes. Yeah. That's okay. I meant output, or I just meant out, one of the two. I'm not sure. But it's okay. Wes?
Do you have any more study guides?
Yeah. Okay, folks, we gotta let me know before I start. Okay, I think I already asked. Does anyone not have a study guide?
I have a study guide at home, but I might as well just want to.
No one cares.
Just be nice.
Sorry, right?
Okay. So now it's between A and B, right? Not sure which one it's going to be. All we have to do now is follow the arrows. We see our input of 6 has an arrow pointing to which output? 4, right? So we're looking for a point that is 6, 4. Well, in option A, we have 6, 3. That doesn't look right. But here we have 6, 4. Now, just to be sure, let's go ahead and look at the rest. An input of 7 gives us an output of what? 3, right? That one's good. An input of 8 gives us an output of also 3. That one's good as well. And an input of 9 gives us 6, right? That one's good. So our final answer is going to be option B. I'm not going to take time passing out red pens just because you're not in groups. So if you have a separate colored pen that you want to correct in, that's fine. Otherwise, you can just correct in pencil. Again, this is all to help you out on the test tomorrow, right? Number 2, we're going to indicate whether or not these are functions. What are we looking for when it comes to whether something's a function or not? Yeah, we're looking at the inputs, right? What type of inputs are we looking for that's going to tell us this is not a function? Matching or repeating inputs, right? Exactly. So let's take a look at the first option. Let's look only at our inputs. We're only worried about our inputs, right? We've got 7, 8, 9, and 10. Are those all different inputs?
Yes.
Yes, they are. That's a function right there. Next one, our inputs are 1, 1, 1, and 1. Do those inputs repeat?
Nope.
Yes, they do repeat, right? It's the same number over and over again. That's not a function. You were answering no. I know what you meant. And then we look down at C. We've got inputs of 3, 4, 5, and 6. Is that one good? Yep, that one's going to be a function as well. Even though our outputs are 4, 4, 4, and 4, it's still going to be a function because repeating outputs don't matter. We can repeat outputs all we want. That's fine. We just can't repeat the inputs, right? Questions on 1 and 2 before we move on? Okay. And I'm actually going to jump down to number 4. While we're talking about mapping diagrams and ordered pairs and all that, let's just jump down to number 4. So we've got a mapping diagram here, and we're going to have to translate this into a table of inputs and outputs. Again, our inputs are always on the left. I did it again. Our outputs are on the right, okay? P and O are too close together in terms of how they look. So, I had some good questions yesterday. Tuesday. People were asking, hey, there's only 3 inputs, but there's 4 boxes. What's up with that, right? Well, let's just take it input by input and see where we go, right? Our first input's going to be 4. So we're going to write 4 as our first input. And let's just follow the arrow. What output is an input of 4 going to give us? 7, right? The arrow goes right to the 7. Then our 4 is paired up with the 7. Lonnie, you want to help me with the next one? What's our second input? 5. And where does 5 go for an output?
2.
Up to 2, right? Very nice. Now, is there anything weird we noticed about 5, Alani?
There's only 1 5.
No, there's only one 5, but there's
2 numbers for the output.
That's right. There's 2 different arrows coming out of 5 and going into our outputs, right? So our second
5.
solution, we could say here, is going to be 5 going to 9, right?
Oh.
There's where that 4th box comes in, because we have a repeating input with a different output. Finally, our input of 8 is going to give us an output of what? 5, right? So, the question is this a function? Give me a thumbs up for yes, it is a function. Give me a thumbs down for no, it is not a function. What do you guys think? Good. I see 100% thumbs down. It is not a function. But why is it not a function? Jordan, how do we know?
Because in the input, the 5 is repeating twice.
That's right. Repeating inputs. All we got to say. Repeating inputs, we can say of 5. So that 5's repeating. We got different outputs. Just think about the brownie analogy, right? All right. Now moving back over to number 3. Number 3 is not really a math problem as much as it is an understanding problem, right? We have to understand what's going on in a graph that looks like this. Does anyone remember a similar problem that had a graph that looked kind of like this? Does it look a little familiar?
No, honestly.
That's right, the plane flying. Thank you, Kaylani. The warm-up on Tuesday with the plane, right? We saw that the plane was going up, up, up in the air. Then it stayed constant for a little bit. Then it went right back down to the ground. Let's use that prior knowledge and try and understand what's going on here. Our x-axis represents time. Our y-axis represents distance from home. That's the important part there. It's the distance from home. Not the total distance traveled, right? So it looks like whatever's going on here, Juan is going to start where? Yes? Just clip them all on there. Thank you. Okay, so we're talking about Juan, right? And here's Juan's starting point on the far left side of the graph. Remember with the plane problem, we always start looking on the left, right? So where does Juan start from? Started from the bottom, exactly, right? What's at the bottom? What does the bottom represent?
Home.
Home. Thank you. Home.
Oh.
The distance from home at this point is 0, right? So he's at home. That's where he's starting. And as we move along this line, we see that his distance from home is increasing, 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 right? That means that he left his house, he's going somewhere. But then we hit this point where we have a nice flat line, right? So that flat line indicates to us that wherever he stopped right here, he stayed there for a little bit of time, right? Time kept on moving, but his distance stayed the same. After that interval of him just kind of staying wherever he's at, we see that this line slopes down, right? Where is that line sloping towards? Home. Thank you. It's going right back down here to the bottom, and he's going to end up right back at home. So now that we understand how to read this graph and we understand what's going on in the problem, let's look at the options. Number 1 is Juan walks to the library at a steady pace without stopping. Does that represent this graph? No, definitely not. A graph like that would look something like this, right? A nice steady pace. That's a linear function, it's going to look like a straight line. So it's not going to be that one. Definitely not A. What about B? Juan walked to the store from home, bought some groceries, then walked back home. Does that represent our graph?
Yes.
Yes, absolutely. That's exactly what we talked through. He started from home. He walked, I guess in this case, to a store. And then he spent some time buying groceries, right? That's what this flat line represents. The time that he was at the grocery store, the distance from home didn't change at all while he was there, but the time still moved on, right? So that one's going to be our answer. But just to clear our bases here, let's look at option C. Option C says, Juan walked to the store from home, bought some groceries, then walked to his friend's house, right? So if we were looking at a graph like this, it would start out looking very similar to our graph. But then where's this line going to go? Up, right? He's going to go further. And obviously we're assuming that his friend doesn't live next door to him or anything like that. We're assuming his friend's house is further away than the grocery store. So keep something like this in mind. Just keep a graph that looks like this in mind. All right? So our answer, yes, our answer was B here. He walked to the store, stayed at the store for a little bit, then walked right back home. Right? We could also say this graph represents a lot of your guys' days, right? You travel to school, you stay at school for a little bit, travel right back home. Really simple to understand, right? I know some of you stay after and all that stuff, but you still end up going home after, I would assume. Down to number 5. Now, number 5 we just talked about with the warm-up, so I'm not going to spend too much time on it. Again, we're just going to take our function, y equals 2. We're going to take the x out, but we're going to leave everything else around that x intact. We're going to take our first input, which is -2. We're going to plug it in right there for x. And then we're just going to evaluate, right? What's 2 times -2 going to give us?
0.
-4, good. 2 minus 2 would be 0, but we'll get there, don't worry. And then -4, we bring down that +3. What's that going to give us? -1, beautiful, thank you. -1, right? Now let's go ahead and plug in our next x value, which is -1. Y equals 2 times -1 plus 3. Okay? -2, right? And then we add 3 to it, and we get what? +1. That's right. 2 times -1 gives us -2. Then we have to add 3 to it, and we get just +1, right? Great job, Kay. Thank you. How do we get from -1 to 1? I'm not going to go ahead and fill out all these equations. I want to just use my pattern. What do we do from -1 to get to +1? We're adding 2, right? Thank you, Kaylon, plus 2. So what's this next number going to be? 3, right? Then what? 5. We're adding 2 each time. That's okay. And then we get 7, right? Give me a thumbs up if your table looks something like this. Now, I did see a couple people with some 7s in the first slot. I think that's just a result of you subtracting 3 potentially instead of adding 3, okay? So make sure you're paying attention to your pluses and your minuses because they're going to mess you up tomorrow if you're not paying attention, right?
You got the -1 from the input? Wait.
So we took the input of -2, we plugged it in right here. Then we multiplied those two numbers, 2 times -2 and got -4. But our b value is +3, so we have to add 3 to that, and we get -1, right? Yeah, Wes?
So I have a question.
Yep.
So you wrote why did you write the 2 1s in red but all the others in blue?
Oh, that's just because I switched pens and I didn't change it. But the colors here don't matter. That was my bad. Does that make a little bit of sense though?
Yes.
Okay, good. Good. Moving on to number 6. Now number 6 comes from our little half sheets that we glued into our notebook. If you don't know what I'm talking about, you definitely got to come up and see me after class or after we're done going over this so you can get those forms glued in. They're going to be super, super helpful for you tomorrow, so definitely don't forget your notebook, okay? We're going to take this function x squared minus 4, and we're going to do exactly what we just did in number 5, except it's going to be a little different because we have an exponent, right? So we've got y equals x squared minus 4. We take out our x, but everything around it stays intact, even our exponent of 2. In fact, especially our exponent of 2. We got to make sure that's there. And then what's our first x value that we're going to plug in? Oh, did you have a question?
So y, the x, so basically the entire thing stays the same except the x.
What do you mean by that?
Because like everything y equals, and then the exponents, and then the negative 4, all that's the same, but then the x is missing.
Absolutely, yep. All we're doing is substituting the x for some open parentheses. That's going to give us space to plug our numbers in, right?
Oh.
The first number being negative 2, right? Now, I know I've said this a couple times, but I really want to make sure you guys know. This right here is not negative 2 times positive 2, right? It's really going to be negative 2 times what? Negative 2, right? If we're squaring it, we're multiplying it by itself that many times. 2 times, right? If we had an exponent of 3, we'd multiply negative 2 times negative 2 times negative 2 3 times, right? Here we only have to do it twice. What is negative 2 times negative 2?
4.
Positive 4, right? Negative times a negative gives us a positive. And then we have to subtract 4, giving us 0, right? So our first output is going to be 0. We can go ahead and plot that point on our graph, starting at the origin. We're going to move on the x-axis minus 2 spaces, right there. And we're going to move on the y-axis how many spaces? 0, right? Thank you, Jackie. 0, right there is our first dot. Let's plug in the next one, negative 1. What would negative 1 squared be? Negative 1 times negative 1, positive 1, right? Negative times a negative equals a positive. Yeah, you mentioned that earlier, right? So we have positive 1 minus 4 gives us negative 3. Right? Thumbs up if you're with me so far still. Okay, thank you. All right, what happens when we plug in 0? What's 0 times 0? 0 minus 4 gives us negative 4, right? Keep in mind, we're subtracting the 4. We're not multiplying. Okay? We're only going to multiply if we have parentheses. But right here, 4 minus 4, like in the first input, no parentheses, right? We're subtracting. So, we plug in 1 next. What's 1 squared? 1, right? It's just 1 times 1. Minus 4 brings us right back to negative 3, right? Is it okay that we have this repeating output here? Yes, that's perfectly fine. Repeating outputs are okay as long as we don't have repeating inputs, right? Then we plug in 2. We get 2 squared minus 4. What's 2 squared going to be? 4, right? So 4 minus 4 gives us, once again, 0. So we started at 0. We went down to negative 3. Down a little bit more to negative 4, then went back up to negative 3, and back up to 0. So if we're plotting these points, negative 1, negative 3, we're going to go left 1, down 3, right there. 0, negative 4, that's our y-intercept right down here at negative 4. We can see right away this is not going to be linear, right? Because those 3 points don't form a straight line. Our fourth point is 1, negative 3. We'll go over 1, down 3. And then we're going over 2 and down 0. Just like that. Anyone remember the name of this shape?
I know. A parabola.
Yeah, absolutely. You guys are on the right track. It's a parabola, right? Parabola. Okay, spelled like parabola, pronounced parabola, right? That's okay. It's very common. And we're going to connect all these points with a nice round U-shaped graph, right? Just like that. try and get it as precise as possible when it comes to actually crossing through all 5 of those points, okay? And we definitely don't want to make a graph that looks like this capital V here. We don't want to see that, all right? We want it to be nice and round, not sharp like that. This is an absolute value graph, and we don't worry about that, okay? Questions on graphing this?
Is this okay? Does this look like a V?
Yes, it looks good. Looks great. Make sure that your lines go through the points and you have arrows on the end, though, Alani. So don't just stop at these 2 points. Just like when we're making a linear function, the arrows go on forever, right? So don't just stop your parabola like that. The lines have to go through the points with arrows on the end, okay? All right. Now, number 7 was cause for a little bit of concern yesterday. I had a lot of questions about number 7. And I think the problem with number 7 is we are not, potentially not understanding what's going on. So let's break it down, right? Can I have someone read out this question for everyone, just to give my voice a little rest? Janae, go for it. Thank you.
A cell phone company charges $30 for their phone plus a monthly service charge of $20. Which of the following are true of situations?
Thank you very much, Janae. I appreciate that. So, what costs $30?
The phone.
The phone, right? So the actual phone, $30, right? Okay. What costs $20?
The service charge.
The service fee, right? So that would be your bill, right? Your phone bill. How much is that each month?
$50. No.
You're talking about
It's
adding it
$30.
It's a
Isn't
nice
it?
looking $20.
$20.
A monthly service charge of $20, right? That's the important piece of information right there. A monthly service charge. So is that $20 something you only have to pay one time, or is that something that's going to get pulled out of your account every month?
Every month.
It's going to get pulled out every month, right? Do you have to pay this $30 over and over again, though?
No, that's when you buy the phone.
Bingo, that's just when you buy the phone, right? So we can call 30 our initial value, and $20 per month we can call our unit rate, right? $20 every 1 month. The second thing we're comparing is 1. That's a unit rate. So the phone itself was only $30. That's something you only have to pay one time. And then the monthly bill for that phone is going to be $20 deducted from your account every single month, right? Okay, now that we know what's going on in the problem, let's write an equation for this problem. We're going to use the equation y equals mx plus b, of course. Now the real question is, which is m and which is b? What's our m going to be here? Is it going to be 20 or is it going to be 30? Give me a thumbs up for 20. Give me a thumbs down for 30. What's going to be our m value here? Up for 20. Wait, what did I say?
You said up for 30, down for 20.
Up for 30, down for 20. Good. I'm seeing a lot of 20s. That's absolutely right. 20 is going to be our slope or our unit rate because it's going to get deducted over and over and over again, right? If you're going 60 miles per hour, you're going 60 miles an hour continuously, right? Over and over again. But if you start 30 miles from home, then 30 is going to be your starting point or your initial value, right? So 20 we have to make sure is our m, which means that what's our b value going to be? 30, right? That's the initial value. You only have to pay that one time, right? Here's our equation. Now that we have an equation, it's going to be a whole lot easier for us to answer these questions, right? Because question 1 is, it is a linear function. Take a look at the equation we just wrote. Is that a linear function? Yes. I'm surprised only a few people said yes. Are there any exponents in it? No. So is it linear? Yes, it's absolutely going to be linear, right? We're looking for exponents when it comes to linear versus nonlinear, right? However, is it proportional? Omar? No, it's definitely not proportional. Why not? Who can tell me why it's not proportional? How do we know? That's okay. That's okay. Adrian, you want to help us out? The y-intercept? We're on the right track. Zalian, you see me. You're going to help us out. Help us out. One more time. It doesn't go through the origin. Exactly. How do we know that if we don't have a graph, though?
Because it's not a 0.
Bingo. Our b value is not 0, so it is non-proportional, right? Yes. Yes. Great job, you guys. Thank you for that. Our b value is 30. If we were going to graph this, we would start at 30 and be moving up like that. That's a non-proportional graph, right? Proportional is going to go through the origin, just like Zalia said. Thank you to those of you who helped us out with that one. So, is the y-intercept 20? Ooh.
No.
Look at our equation. Is the y-intercept 20?
Yes.
No, it is not, guys. The y-intercept we just said was 30. We just said it was 30.
I got it wrong.
So we established now, we all know we're all on the same page, our y-intercept is 30, right? Give me a thumbs up if you agree that our y-intercept is 30.
Yeah.
Beautiful. Let's look at the next question. The slope is 30. Is that true?
Yeah.
No.
Wait. No.
Okay, guys, it's all right. This is why I wanted to spend time talking about number 7, because it's confusing, right? We established that the y-intercept was 30. The next question is the slope 30?
No.
No, definitely not, right? The slope is 20. But this is where the confusion comes in. That's why I want to talk about this. So thank you. I appreciate all incorrect answers because they help us learn, right? I'm incorrect all the time. I write put instead of out, right? So the fifth one is the equation is y equals 20x plus 30. Is that true?
Yes.
Yes, yeah, it is, right? That's the equation that we wrote at the very beginning. Now,
I got them all wrong.
the sixth one is the total cost for 4 months of service is $120. We don't have a table. We don't have a graph. We can't extend anything. How are we going to figure this out? Crystalline?
You multiply 20 by, or you multiply 4 by 20.
You multiply 4 by 20, right? What does that give us?
60.
Close.
So 80.
80, right? Now, and then what do we have to do?
You have to add your additional cost.
Thank you. We also got to add 30, right? So here's what we're actually doing. Let me explain this a little clearer. We got y equals 20x plus 30, right? Where x represents our number of months. If it's $20 per month, x is going to be our number of months, right? So if we're looking for the total cost, that's our key word, is total cost. For 4 months, we're going to plug in 4 for x. Jules?
I'll go get water.
Go ahead. So we're going to plug in 4 for x. 20 times 4 plus 30. Just like on number 5 when we were evaluating our table. 20 times 4, like we said, gives us 80. And then we have to add 30, giving us what? 110. So is the total cost for 4 months of service $120? No, it's really close, but it is not. So this is the thing. With a question like this, if you flip the y-intercept and the slope, you're going to get all of the questions wrong because you're going to be looking at it from the opposite perspective, right? That's why I stress so much understanding what's going on in the problem is always going to be our first step when we have a word problem like this, right? Okay. How much time we got? We got time. Let's flip over to the back side real quick. We'll go over the last couple of problems. There's only 3 of them.
So the answer was no.
The answer was what now?
Answer was no.
For the last one, yes. Yeah. So number 7 was yes, no, 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 yes, no.
I thought it was yes, no.
No, it was yes, 3 no's, a yes, and then another no. Okay. All right. So, number 8, we are describing functions here. I think was 6.2, right? Describing functions. We're trying to determine whether these are linear or nonlinear, and whether they're proportional or non-proportional, right? So let's take care of linear first. What are we looking for when it comes to linear versus nonlinear? Exponents, right? If there's exponents on our equation, it's nonlinear. If there's no exponents, it's linear. So of these 4 equations, which of these is going to be nonlinear? C, right? We've got that exponent of 2. We know right away that it's non-linear. What about the other 3? The other 3 are all linear, right? There's no exponents on any of the other ones. So we know that they're all linear right away. Now, when it comes to proportional versus non-proportional, what are we looking for there? We're looking for a straight line that goes through the origin, right? Great. But if we only have an equation, what's the thing that we're looking for? That's right. We're looking for a 0 as our b value. Do any of these equations have a b value of 0?
Yes. B.
B, right? I don't see a number being added on the end. It's got to be a phantom plus 0 there, right? So does that mean that option B or question B is proportional or non-proportional? It's proportional. What about A? Is A going to be proportional or non-proportional? Non-proportional. Our B value is 5. What about option C? Definitely non-proportional. Even if this plus 3 wasn't there, is it still going to be non-proportional? Yes. Why?
Because it's not linear.
Because it's not linear, right? Proportional relationships have to be linear, and they have to have a b value of 0. Like option B. Question B, we established was linear. There's no exponents, and there's no b value, so it's also proportional. And option D is definitely going to be non-proportional because of that minus 3 on the end, right? Oops. All right. Moving on down to number 9. First, we got to find the slope of the y-intercept. Yeah, that's fine. Go ahead, Mama, real quick. So, what's our slope here on f of it? Actually, let me take a step back. Let me take a step back for a second. So this is from our lesson 6.3. It was the last new lesson of this unit. Stay with me, guys. 6.3 was the last new lesson we learned in this unit on, I think it was last Friday, so 6 days ago. And there's kind of a lot that goes into it. So we're going to break this down. We're just going to take it slow, go step by step, and we're going to figure it out. Let's start with f of x. We got to identify the slope and the y-intercept, right? What's our slope here for f of x?
-1/2.
Thank you, Lily. -1/2. Whatever number's in front of x, y equals mx plus b, that's going to be our slope. So what's our y-intercept here?
3.
Positive 3. That's our b value, right? If you forget, you can go ahead and write this. It might be helpful. But at this point, I'm assuming we should know. We've been talking about slope for what seems like years. Now let's take a look over at g of x, because after all, we are comparing these two functions. Now g of x is a little bit trickier to figure out because we've got a table. The table's not even finished, right? What's our change in x on the top of this table?
2.
How do we get from 2 to 4?
Plus 2.
Plus 2, right? Now let's take a look at our change in y. How do we get from 1 to 4?
Plus 3.
Plus 3, right? Plus 3. So let's fill out our table. If we add 3 to the right, what number is going to be after 4?
Plus 7. Or 7.
7, right?
The first one is
And if we're adding 3 to the right, what are we going to do to the left? Subtract 3, right? What would 1 minus 3 give us here? Negative 2, right? 0 minus 3 would be negative 3.
bro.
So we get negative 2. So, what's our slope going to be here? Negative 2 is very close. Negative 2 is actually going to be our y-intercept, right? Because the y-intercept is wherever x is equal to 0.
3 over 2.
What's our slope here going to be?
3 over 2.
I heard it from a couple people. Yeah, it's going to be 3 over 2. It's our change in y over our change in x. Yes? Positive 3 over 2. So we got our slopes, we got our y-intercepts. Now let's go ahead and describe these two functions. F of x. Give me a thumbs up if f of x is linear. Give me a thumbs down if f of x is non-linear. What do you guys think? Up for linear, down for non-linear. Good, I see mostly thumbs up. This is linear, right? How do we know just from the equation? We don't even have a graph. How can we tell from this equation that it's linear?
Because it's not exponent.
No exponents. Exactly. No exponents. Now, is f of x proportional? Give me a thumbs up for proportional, thumbs down for non-proportional. What do you think? Perfect, perfect. Good, 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 good. Okay, yes, it's non-proportional, right?
Yeah,
How do we know?
because the 3 is a 3, not a 0.
The 3 is a 3 and not a 0. Perfect. Couldn't have said it better myself. That's exactly right. Our b value is not 0. We only have proportional relationships when our b value is 0, right? Okay, let's take a look over at g of x. Give me a thumbs up for linear, thumbs down for non-linear for g of x. What do we think? See a lot less thumbs this time, but the thumbs that I do see are up, right? It's a little bit trickier to figure out when there's no equation to say, well, is there exponents or not? So without an equation, how can we figure out if this is going to be linear or not?
Because it's not like twice. Oh, no, that makes sense.
I think I know what you mean. You're on the right track. Well, is there a constant change in x and y?
Yeah. Yes, when it's not a constant change.
Absolutely. There was a constant change in x and y. We know that because we found a slope to begin with, right? There's a reason why we haven't found the slope of any parabolas. Because you cannot find the slope of a parabola. It would be, the rise over run would be different in every single place that you check. So if we can find a slope at all, we know right away that it's linear. Another thing we could do is we could take m and we could take b, and we could write our own equation. Y equals 3 over 2x minus 2. Do you see any exponents there?
No.
No, so it's definitely going to be linear, right? Is it going to be proportional or non-proportional? Show me on your thumbs, up or down. Proportional or non-proportional? Thumbs up for proportional, thumbs down for non-proportional. Ooh, okay. So, what's our b value? Is it 0?
Yeah.
No, then it's non-proportional. Right? So the thumbs down crowd took that one.
That's what I was looking at.
Non-proportional, right? Which one were you guys looking at, you said?
0 and x.
Oh, yeah.
Look at the
Yeah, if the y value there was 0, it would definitely be proportional. But our y-intercept right down here is negative 2. Great catch. Great point. Perfect. Now let's finish off with number 10. And it looks like we are getting close. But we'll get through it. So number 10. Water is flowing into a pool at a constant rate. Constant rate, that's a nice thing to know. Represented by the equation y equals 30x. That's going to help us out a lot. Y represents our gallons in the pool, and X is our time in minutes, right? We can see that right here on our axis labels. Yes?
Oh, aren't we supposed to find which is deeper?
Great point. Totally forgot about that. Thank you, Crystalline. We forgot to find out which line here is steeper. And this is important because, like I said, we just talked about this. What are we going to look at to determine steepness? Are we looking at the slopes or are we looking at the y-intercepts? We're looking at the slopes, right? Think about it. The slope of a line determines whether it's straight up and down or if it's flat, right? So if we're comparing how steep these lines are going to be, we have to look at the slopes, right? Think about a steep slope, okay? So the slope of f of x is 1 over 2. Slope of g of x is 3 over 2. Notice how I didn't put the negative sign here. Remember, when we're comparing for steepness, just we're going to take the absolute value, right? Just make it positive. We don't have to worry about negative signs. We're comparing the size of the numbers. Which of these two fractions is larger? 3 over 2, right?
What?
3 over 2? 3 over 2 is 1.5 and 1/2 is 0.5, right? It's okay, don't worry. They won't both be fractions tomorrow. One of them will be a whole number, so it'll be easier for you. But 3 over 2 is larger. Does that mean that g of x is steeper?
Yes.
Yes, it does. G of x is steeper. Not by a whole lot, but it's still going to be steeper than f of x. Now let's take a look down at number 10 before we're out of here. Our equation we're going to use is y equals 30x. Now, we could just use the equations right off the bat and plug in 0 for x, right? That's our first input here. What would that give us for an output? 30 times 0? 0, right? And that makes sense within the context of this problem. After 0 minutes of filling the pool, there's 0 gallons in the pool, right? Which means we haven't even started doing it yet. What if we plugged in 1 here? What's 30 times 1? 30. 30 times 2? 60. And then we can see that we're just adding 30 each time, right? This is nice and proportional. So the next one, thank you, is going to be 90. What's after that?
120.
120. Nice. Now, we're going to plot these points. Whenever we're doing a word problem and we got a graph, we have to look at the axis, right? Because time is going by 1, 2, 3, but our water is going by 20, 40, 60. So we're going to plot 0, 0 right there at the center. But our next point, 1, 30, I don't see a 30 on my graph. Where am I going to put this point?
In between 20 and 30.
Bingo. In between 20 and 40, right there is our 30. So you can fill in all those empty gaps with your odd numbered gallons. If that helps you understand what's going on. 1, 30 is right there. 260, 390, 4, 120. I'll make sure you guys all have rulers tomorrow so that you can graph your lines nice and straight. We're not going to worry about it right now. Is this relationship linear?
Yes.
Absolutely. That's a very straight line. In fact, it's also, what can we call this function as well? Proportional. Bingo. Good. Not that it's a question on here, but just reviewing. Now we're going to predict the amount of water in the pool after 6 minutes. Now there's 3 ways we can go about doing this, okay? 3 different ways. The first way is what I would not recommend you do, and that's extend the graph, right? If we extend the graph up, then we can get up to 130, 140, or over here to 6, right? I don't want you to do that. Huh?
Should I go now or what time?
Yeah, that's fine. So I don't want you to expand the graph. What I want you to do instead is one of these 2 things. We could either plug in 6 for x, just like we did before. What would that give us as an answer?
180.
30 times 6 is going to be 180, right? What's our units on 180? Is it 180 pools filled? 180 gallons of water, right? We can just put gallons. The other way we can go about doing this, which is, I believe is what some of you did, is we can extend our table, right? It's a lot less messy to extend our table as opposed to extending our graph. Don't do that. Then we just finish the pattern, right? We're adding 30 to 120. That gives us what?
150.
150. And then we add another 30 and we get
180.
180, right? Same answer either way. We get 180 gallons after 6 minutes. If we had enough room on this graph to expand it, we could see that for a third time that after 6 minutes, we've got 180 gallons of water in the pool. So this test is only going to be 12 questions. It's kind of a physically long test. It's front and back and then a third page as well. That's because, look, I mean, the back side of this worksheet is 3 problems. They take up a lot of space. So when I give you a stapled test tomorrow, don't freak out. It's still only 12 questions, okay? Make sure you have this study guide. Go ahead and start packing up, but please don't start talking. Make sure you have this study guide tomorrow. Make sure you have your notebook tomorrow. And make sure you have, I don't know, a good rest of your day.
Look at me, Mr. Church. 55 out of 60 on my Holocaust project.
Great job.
I'm like that.
Great job, Jordan. 55 out of 60, that's
I
awesome.
got a 60 out of 60.
Why are you lying?
I got a 60 out of 60.